Hey guys, for our presentation this week, we were told to solve problem number 2 from page 133 in the textbook. And the setup for this problem says that last week we talked about the quadratic equation x squared plus bx equals c. And we solved this using completing the square. Now, this question asks us to solve something of the form x squared equals bx plus c. Now, normally today we would just move everything to one side and use the quadratic formula to find it, but the question wants us to find this using a geometrical approach. So basically we need to do something similar to completing the square, but it's going to look a little different. So our first step would be to draw a square just like we did last week. And we got our square, and we're going to say that each side is x and x. So that means the area of this entire thing is x squared. So we have this part of the equation. Now we need to break it up into two parts. We're going to break it up into bx and c. And to do that, we're going to basically draw two rectangles. So we're going to draw two rectangles. We'll start out with the first one. We'll just say it's right around here. And we're going to define this guy as side length b. So the area of this guy is bx. So we have one part. Now for the c, all we're really going to do is we're going to call this area, the right side rectangle, we're going to call that c. And I'm going to make a rectangle just to have visual representation of that. So yeah, this area is going to be c. And so this length here is still x, and we can use arithmetic to say that this length right here is x minus b. So c is going to be x minus b times x. And if we plug that into this equation right here, this guy right here, we're essentially going to get x squared equals x squared. So we need to go a little bit further with this. So what we're going to do is we're going to break the left rectangle, the green one, into two parts, similar to what we did for completing the square. And I'll do that right now. Okay. So now we'll say this side length here is b over 2. All we did is we split the green rectangle in two. And all I'm going to do, I'm going to make a second copy so we have a visual representation. What I'm going to do a little trick with this one. So all I'm going to do is I'm going to rotate it 90 degrees, and then I'm going to move it down here. Because we know that this side length is x, and this yellow side length that I just highlighted is this side length as well, because they came from the same green rectangle. So this side length here is still b over 2. So we still have the same rectangle. It's b over 2 by x. So what we can say is the area of the red rectangles is x times b over 2. So because we moved the rectangle that's now on the bottom, this space, this red space right here, is no longer part of this square. And this purple space here, that's being doubled up because you have one red rectangle going this way and one rectangle going this way. They meet here, so it's basically doubled. So that's a fun little party trick for the green rectangle. But what about the blue rectangle, the one that represented C? Well, we have this region here and this region here. We have a big rectangle and like a skinnier, smaller rectangle here. Those both represent C. So I can say C equals the 1 and the 2 combined. Now I'm going to make some annotations of specific lengths on here. So this side length here is still x minus b, which means that this side length is x minus b as well, and this one as well. This side length is b over 2. This side length is b over 2. And what about this one here, this bigger one? Well, since this entire thing is x, and this guy right here, the portion on the bottom is b over 2, this is just x minus b over 2. So that means this thing is x minus b over 2. Since we have all of those lengths annotated, we can say that region 1 is defined, its area is defined as x minus b times x minus b over 2. And the second region is defined, its area is defined as x minus b times b over 2. And since this equals c, what we could do is we could add these two guys, plug it back into the equation we started with, but we're going to get the same issue that I mentioned at the very beginning. We're going to get x squared equals x squared, which doesn't really tell us much. So let's keep going. Now, you might notice that if this side length is b over 2, and this side length is b over 2, this side length here is also b over 2, which means this side length is also b over 2. So what we can do is we can move this region, number 2, we can put it up here. And I'm just going to represent that with this dashed orange rectangle. So this is now 2. And 2 is no longer in this area. We'll kind of scribble that out. Now, because we put it up here, it still retains the same shape, so it retains the same dimensions. So b over 2, that's this guy right here. And then this x minus b is going to be represented right here. So that means for this length here, since we know that this entire length is x minus b over 2, we need to break it up into two parts. One of them is x minus b, the other is going to be b over 2, because this guy is x minus b over 2 still. So now we have this little square right here, right? This red square. We know the dimensions of this square. It's just b over 2 and b over 2. So the area of this guy is going to be b over 2 squared. So now we have this square, this yellow square, represented in terms that we know. We can actually find the area of that. We said c is equal to 1 plus 2. So this guy and this guy, those two rectangular regions are represented by c. We also have this smaller square right here, which is b over 2 squared. Okay, so we have x minus b over 2 here and x minus b over 2 here, which means that the area of the yellow is just a square of dimensions x minus b over 2 times x minus b over 2, which we can write as x minus b over 2 squared. But without using the dimensions, we know the areas of region 1, 2, and this little square, the red square as well. Region 1 and 2 is C, and then the third region is B over 2 squared. So now we have the area of the yellow square represented in two equations. So let's just set them equal to each other. So if we set them equal to each other, let's solve for x. So we have 1x now. We're not working with an x squared like we did at the beginning. So let's solve for x. So if we take the square root of both sides, we will get the square root of c plus b over 2 squared equals x minus b over 2. Well, if we solve for x, we're going to get x equals b over 2 plus the square root of c plus b over 2 squared, which is what we want. So there we have it.